All right, class. Hello, good morning. How we doing? All right. So, now, for those people that got locked up for selling drugs, pay attention. All right, anyway. All right, so we're going to go over this, and you guys all should have your notes out right about meow, okay? Jess. Jess. Okay, so this one right here, so this should explain a lot because it's some of the stuff that we've already talked about, and it's some of the things that we only talked about it. We actually haven't done any of the problems yet. So let's go ahead and do some of this. So what is this symbol right here? So this is the approximate, and these are my bounds that we were talking about, and this is going to be from 1 to 9. Jess?
Yes.
Okay, 1 to 9. My function is going to be x minus 3 squared and dx. What do we say dx is? Delta x, right? Yeah. Delta x, and that's going to be, delta x is the thickness of each one of my slices, right? Yeah? Yeah, so for each one of these rectangles that I'm making, I'm going to have a delta x. That's the thickness of whatever it is. So 1 to 9, 4 sub-intervals with a length of 2. So if I'm doing my math and I want to figure out my delta x, it would be 9 minus 1 is divided by n, which would be, which gives me, so my delta x here is, okay, so good. So left Riemann sum. So now we're going to choose the left point. All right, so let's take a look. We started this. Did we start? We started this one, right? Yeah. Yeah, okay. So, because I know I didn't end up finishing it. Doctor! Wait. Dr. Garrett. They were telling me that you are Garrett.
Yeah, spelled wrong. Last name spelled wrong. Nice efforts.
I know, right?
God, if I had feelings, they'd be hurt.
I know. Do you know what? Because they were quite possessive of you. They referred to you as my cow, and I had them at least change that. So.
I could live with that.
Okay. So right here we're actually starting with left interval. Okay, left interval. So let me go. Insert page. Blank after current. All right, so let's set up my interval again. So it's going to be, because I got to rewrite it so the doctor can know what we're doing. 1 to 9, my function is x minus 3 squared dx, where n is equal to 4, and what do we say? Delta x, it gave it to us, right? Yeah, so that's the thickness of each one. So we're going to take this, okay? We're going to take this and I'm going to partition it. So first thing I'm going to think about is I would like to break it up into my separate parts. So I'm going to take a look at my intervals. So my first interval would start at 1. Very good. And it goes to 3. Riemann sums, doctor. My second interval starts at, and it goes to. Next one starts at, and it goes to. And my last one starts at, and it goes to. There he goes. There is my 4 intervals. Those are the x values of my left side and right side of each one of my rectangles that I'm using. Okay? Yes? Okay, so now we know each rectangle should look like this. So it's going to be like this, and of my function it should be something like this is not to scale, NTS, not to scale. So in this case right here, if it's left hand, so I need to try and make the rectangles connect right here, where this one would be x comma f of x, right? That's where my point's going to end up at. So x comma f of x. So my f of x is whatever this x value is, plug it into my function. And in this case, my function is going to be this. So let's see. So we know that my delta x in this case is going to be, say 2, right? Because it's going to be, for each rectangle, it's length times width, so it's going to be a 2 times my f of x here. Okay, so plug this in. So 1 goes into here. So 1 minus 3 is -2. -2 squared is 4. So this is my value here. Plus, because I'm adding together all the areas total, because it's the sum of each of these. So now, again, my delta x is going to be 2. And now, since this is left side, I'm now plugging in which one for my next rectangle? 3. So 3 minus 3 is 0. 0 squared is 0. Now, let's see. Next one is going to be my delta x, which is 5, times... Oh, wait, dang it. See? Making sure you're paying attention. Delta x is 2. And I was... Okay, there we go. Delta x is 2. And then, what is my function value? F of x here? 4. It's going to be 4. And my last one. Delta x is 2. 16. There we go. And so since we're trying to make a formula out of this and try to simplify a whole bunch of my work, do I have a common factor out of this? I have a common factor, which is my 2, right? So I can just go ahead and just be like, all right, let's multiply and add them together, right? But eventually we're going to get into a little bit more complicated of problems, and you're going to want to have it as easy as possible. So all of these has a delta x, right? So it's basically going to look like this. My delta x, which would be a 2, times, because I'm factoring that out of all of these. And this first one would be f of 1 plus f of 3, right? Plus f of 5 plus f of, there we go. Now, why do you think I actually wrote it out like this, in this manner? Yes, handy dandy calculator. Okay, calculator is super helpful on some of these because you're going to get some nasty ones later on. So I'm writing it out like this so you could actually see. This is what we did. We plugged in our function, and you could see where they're going and where it's coming from. So let's go ahead and figure out what the area is, and this is going to be my left Riemann sum. So it's 8 plus 0 plus 8 plus 32. 48? 40?
32 plus 8 plus 8. 48. Oh, you're right.
48? Okay. So that means that my area is 48 units squared, right? Okay, that one's from the left, right? Okay, let's try the right side now. Let's do a right Riemann sum. So if I'm going to do a right Riemann sum, which function, or I'm sorry, which x values do I use? The right ones, don't I? Okay, so I'm doing the right ones. It's going to be 3, right? But is my delta x the same here? Same delta x, so I can actually write it out like this, right? So it's going to be 2 times, okay, so it's going to be 3. So I'm plugging in 3. So f of 3 is going to give me 0 plus, the next one's going to be f of 5. So f of 5 was 4, right? F of 5 is 4 plus f of 7. F of 7 gave me plus f of 9, which is, there we go. So writing it out like this, if you notice it comes out to be easier and easier because I factored out the 2. I just add those together and multiply by 2. So that's going to be, let me see, 2056 times 2, which is 112. There's 20, right? There's 20 plus 36 is 56. 56 times 2, 112. 112 units squared, right? Wow, that is a huge difference, isn't it? Okay. Okay, so now the next one that we're going to do, is the midpoint of the Riemann sum. So midpoint, so if you guys remember this from the other day, we were talking about where we get midpoint from. Okay, midpoint is going to be,
What is that, B minus A?
not b minus a,
A minus B. A plus B over 2.
a plus b over 2. Because b minus a, doesn't that give me my slope?
Yes.
Yes, that would be the slope, wouldn't it? So the b minus a, let's try to remember how we do it, because for these ones, if you do the minus, yeah, that's how we were getting the slope for stuff. But this is going to be a plus. So a plus b, where a is going to be the left side and b is going to be the right side, and then divide those by 2. Because I'm taking the midpoint or the average in between these two. So we have a wonderful problem that actually doesn't have a fraction here. So these are always good. My delta x is still the same. So my delta x is going to be 2. Now, let's take a look. So my first interval, it would be a plus b. So 1 plus 3 is 4, divided by 2 is 2, right? Yes? Yes?
Yeah.
So, what number am I plugging into f of x here? 2. Now it's going to be f of 2 now, right? So this one should be f of 2. Yeah.
So each interval is A, B,
Yeah, a and b, right?
and then we just add them, divide by 2, and then that's
Yep.
the function.
Yep.
Okay.
And so that's the number, that's the x value that goes into my function. So this time we said it's 2, which would give me -1. -1 squared is +1. Now we're doing the next one. So for my next interval, would give me 3 plus 5 is 8, divided by 2 is, and I'm plugging in 4 now. So 4 minus 3 is 1, 1 squared is 1, right? There we go. My next interval, 5 plus 7 is 12, divided by 2 is, and let's plug in 6. So it's going to be 6 minus 3 is 3. 3 squared is. My last one is going to be 7 plus 9 is 16 divided by 2 is 8. So we're plugging in 8. So 8 minus 3 is 5. 5 squared is. There we go. And we come up with.
Yeah, 72.
So right in here we come up with, let me see, that's 35, 36 times 2, 72. That's not too bad, right? Watch room. You feeling okay?
Yes.
Okay. Okay, you okay? I'm worried that you're getting sick. Are we okay now? Not bad, right? So conditions that guarantee a definite integral exists. Defining the definite integral from a to b of f of x d of x, we assume that a is less than b. So we read these things from left to right. We read it from left to right. So if it is not less than b, okay, so whenever we're doing this right here, given the following conditions, so from right here, if this is defined, it's defined, right? It's some function. Remember when we were doing this the other day, I showed you guys, and we did a top minus a bottom, right? We had a function, I did the antiderivative, and I plugged in this number, okay? And I plugged in this number, and I did a top minus the bottom. It's always going to come out like this. And this is why I showed you guys. I did that one problem where I say that the c's go away. When we do definite integrals, c's go away. So this one, if they are the same bounds, so from a to a, think of this. So from a to a, what is your delta x? 0. So the thickness of your rectangles are going to be 0. So the area of each rectangle that we have has to be 0. There we go. And that's where we get this from. Now, in the case that sometimes it is not a is less than b, okay? If it is not, if a is bigger than b, because you're going to get some of these sometimes, we could change it up. So all we have to do is switch it to be correct and then negate it. So if a is bigger than b, I could switch my bounds. Okay, I'm going to switch the bounds. But if you switch the bounds, you put a minus sign out front. That's all you're doing. So we'll work with that a lot more later. And guess what? That's it. So, did I answer the questions that were on the homework that you were struggling with? Some of the things, because it was talking about bounds and it was talking about Riemann sum. Yeah? So, now, I'm going to give you guys the rest of this time. I would like for you guys to please work on the calculus. Okay, try not to sleep because everyone's working. All right. Don't forget, like, share, and subscribe. Hit that notification button.